Hello grade 8 students, our topic for today is about representations of relations and functions. So first we will define what is a relation. So a relation is any set of ordered pair. The set of all the first coordinates is called the domain of the relation. And the set of all second coordinate is called the range. So our given example, so these are the set of the ordered pairs. So remember that the ordered pairs are enclosed with a bracket and braces, a parenthesis and braces. So given example is a set of ordered pairs, so 1 and 3, -4 and 2, 0 and 8, and 9 and 3. So to find the domain, so all the first coordinates are the domain. So 1, -4, 0, and 9 is the domain. So 1, -4, 0, and 9. So these are the domain of the given ordered pairs. And then next is the range. So the range is the set of all second coordinates. So this is your range. So 3, 2, and 8. So we will not write 3 because they are just the same. So the set of all first coordinates are the domain, and the set of all second coordinates are the range. So give an example. Determine if it is a relation or not. So first example, 1, 3, 5, and 7. So is it a relation or not? So the answer is not a relation. Why? Because it is not a set of ordered pair. So it is just an element. So this is not a relation. Next, number 2. Given 2 and 3 and 4 and 5. So this is also is not a relation. Relation because this is just a set of pairs or set of pairs of sets. Number 3. So number 3 is a relation. So it is a relation. So we can now identify the domain and range of a given set of pairs. So its domain is 1, 2, and 3. And its range is 4, 5, and 6. So you can now determine if it is a relation or not. Next is a function. A function is a relation in which, first, for each coordinate, there is exactly one second coordinate. And then number 2, for every first element x, there corresponds a unique second element y. So note or remember that every function is a relation, but some relations are not functions. So example, so now we will determine which of the following relations are functions. So given number 1 are the set of ordered pairs or the relations. So 4 and 10, 2 and 8, and 4 and -7. So number 1 is not a function. Why? Kasi yung element or x, yung x is same sila, which is 4. So dapat hindi pwedeng maulit yung numbers ng or given element ng x, which is 4, o kahit anong number, hindi siya pwedeng maulit. So, number 1 is not a function. Okay, number 2. 1 and 4, negative 7 and 3, negative 1 and 2 and 8 and 4. So, number 2 is a function. Since yung x niya is walang naulit na number, so this is a function. Number 3, 6 and negative 1, negative 7 and 5, 8 and negative 1, and then negative 2 and 0. Number 3 is a function. So, kahit maulit yung given dito sa y, walang kaso yon kasi yung tatandaan lang natin is yung pwedeng maulit na number sa given na x. So, yung y, walang, kahit maulit yung number nila which is negative 1, so function pa rin yun. So, number 3 is a function. Number 4, 0 and 0, 1 and 1, and then 2 and 2. So, number 4 is a function. And also, number 5 is a function. Representations of functions. So, a function can be represented by using a table of values or a set of ordered pairs of numbers, by mapping, by picture or graph, and by equation and by rule of correspondence expressed in words. So, given example is, Roel Emlano, a working student, works in Happy Bee Food House. So, as a waiter, he earns 40 pesos for every hour of a service. Represent the earnings of Roel as a function of hours he works. So, a given problem here is a representation of a function. So, a function can be represented by, first is using a table of values. So we will use table of values. So, number of hours or H and the earnings. So, you can select a random number. So, I choose 10, 11, 12, 13, 14, 15, and 16. So, you will just multiply the given number of hours to the amount he earns for every hour of Emlan or Roel's earnings. So, 10 times 40, 400, 11 times 40, 12 times 40, 13 times 40, 14 times 40, 15 times 40, and 16 times 40. So, that is now on how to represent our function using the table of values. So, you can also represent functions in a set of ordered pairs. So, we will just base the set of ordered pairs in our given example. So, and the table of values, so 10 and 400, 11 and 440, 12 and 480, 13 and 520, 14 and 560, 15 and 600, and 16 and 640. And you can also represent functions using mapping. So, in the other side, we will label it as the H or the R's. And the next is E or earnings. So, this is an example of a mapping. And the next is one-to-one correspondence. So, each element in X pairs with only one element. So, we will label it X and Y. So, the element of X should correspond the element of Y. So, one element of X and only one element of Y. So, a Y. This is an example of one-to-one correspondence. So, next is many-to-one correspondence. Each element in X pairs with only one element in Y. So, give an example X and this is Y. So, the elements of X, which is 1 and negative 1, is paired in only one element of Y. Next is one-to-many correspondence. So one number in X is paired with different numbers in Y. So there is only just one element in X, and an element in X is paired with different numbers in Y. So that is one-to-many correspondence. So note that a one-to-one correspondence and a many-to-one correspondence are called functions, while one-to-many correspondence is not.